All right, so today, so a bit of background of my research. Originally, I did research in efficiency productivity with specialization in agricultural production, and moving on to a bit of development and analyzing, the behavior of business in adopting new technology. And then I started working with Saga's research group, and then learned a lot about technology in the ag space. And then it came up with a few of research projects and grant application, and the idea of carbon technology, and together that with the potential to generate a lot of money, which we don't know in the context of emerging and quickly growing carbon credit markets nationally and internationally. So I thought maybe I would like to share a little bit of knowledge, very new knowledge about this to everyone. So basically, agriculture actually is faced with three main challenges with the climate change. Firstly, they need to work on how to adapt their production to changing climate conditions. At the same time, they need to do something to just produce more to meet the increasing demand of food globally and nationally. And the last thing, more like trickily to do, that would be how to mitigate emission better, right? So all of that put in the context for the sustainability of agricultural systems, of food systems, right? Now it's more, it's actually harder. So when we talk about mitigating emissions, not only that the sector needs to reduce emission, but they also have to think, innovatively how to withdraw CO2 from the planet, from the atmosphere. And then we talk about a new technology that QUT can play very important role for the global economy actually. So the latest research shows that actually more than a third of the global emission comes from food systems. Right? So it's really much more than 10%, more than what we believe to be. In the past, around 25%. Now we talk about 34%. And of course, that we look at the supply chains, that different proportions at different stages of the supply chain. And even though in terms of percentage contribution, they get smaller, but in the magnitude, the emission continue to rise nationally and globally. So that the latest research in Nature. In the context of Australia, this is how Australia looks like compared with the top polluting economies, and this has come from agricultural productions only. And if we talk about another issue with agricultural production is actually waste, right? And we talk about biomass waste as well as food waste, and a significant amount of waste. And the issue actually become more challenging and damaging to the environment in developing countries when most of these wastes are basically burned in the open field. And when you burn this biomass, basically a lot of pollution generated. Right? So the issue become more serious in developing country or less developing country. The technologies are there to solve the problem, but it needs a lot of investment, right, to deal with the problems. And for in the context of Australia, if we look at this, so you see a lot of organic waste generated in Australia. That in 2018 and 19, more than 15 million tons of organic waste. Now, if we talk about waste, we think of they're useless, but in fact, the technology can turn that waste into high-value products. And we talk about later when we talk about the carbon technology, turning waste into high-value carbon products, right? So it means they're huge, and on average, from my understanding, at least 30% of the biomass can be go into carbon products. So every year, we can make 5 million tons of high quality carbons. And the carbons can be used pretty much everywhere in our life, right? It's if you need clean air, you need carbon. If you need clean water, you need carbon, right? If you need more sustainable products, you need carbon. Right? So carbon can be used really much in a lot of aspects of our lives, and that makes our sectors more sustainable. So there are many solutions, to be honest, and I don't know a lot of them, to be honest. But I know two things that can work together amazingly, right, and go into the future. So we talk about carbon credit system that Sam mentioned early on, and another part would be negative emission technology. Right? So we talk about technology that actually store the emission into hard carbon that will not emit back to the atmosphere again. So this is the carbon markets, global market. So basically, you see a big jump in the early 20 up to 2012, and that's where we got a crash in the market. And the reason for that, because the EU emission trading system came into place, and they have a financial crisis, and that's why it had to crash. But later on, the market start, moving, and we hopefully, after. So we don't have the data, recent data, but that hard looks like, unfortunately. But it's growing, right? And in terms of markets, in most of the economies, we have two types of market. We have mandatory markets, we have voluntary markets. And the voluntary market, recently, the statistics show that it grows significantly. And a lot of business, especially global international firms, they're very keen to participate in voluntary markets. Part of that to offset, but also may generate the money, right? So in terms of farmers, Sam talked about aggregators. So that's what normally the farmers are, have been doing. That's conventional way of participating in the carbon markets. And because of that conventional way, we look at agriculture is very little compared to other sectors of economy. But imagine that agriculture can work with manufacturing, that will big jump in the future, right? So we need a collaboration and work together across the sectors in the economy. All right, so this is within agricultural sectors, and look at the number of projects over the last 7 years. And again, you see that the percentage is very small, basically. All right, so the second aspect that I would like to touch on is about the negative emission technology. So basically, there are classification of 6 types of technology. And the story I would like to bring on today is a biochar. It's a very interesting story. So biochar, so actually more than 15 years ago, people talk a lot about biochar, right? And not only that, not that it was developed 15 years or developed a long time ago, but it started getting more popular 15 years ago. And actually, biochar was among the first, negative emission technology that can provide a significant sequestration impact, right? So that it has a huge, promising potential, not to just reduce emission, but actually mitigate, put carbon into a sink. So that only 3 years ago, it started listing in the voluntary market. And then another market came up, and Vera, Vera, one of the biggest verified company, just released a methodology this year. So it took how many years? 16 years for a very simple technology to be transitioned into the large scale in the markets. So that's a huge.
Sorry, biochar, is it a soil alternative, is it? Or
Biochar actually a carbon products.
so it captures amendment.
And sorry, you could take almost any biomass and produce almost like a type of coal or charcoal, sorry, I should say.
Okay, yeah.
And that traps the carbon in a form that allows you to use as a soil amendment. Wow.
So conventionally, it's used for soil amendments, but now there are methodology for biochar to be used in the productions of building materials, the coatings, and really much a lot of things. Everything we need carbon, biochar can go there, right? So this is the movement of the price of biochar credits, right? So it's growing, and the price are very, very promising, right? So we got, so at the moment here has three methodology for biochar, and the most, higher price would be for construction materials. Vera came out, right, very big in the market, and if you look at the feedstock, so biomass sources that you can basically go through a thermal process and a chemical processing process, and it turns into biochar. So these are the sources of materials. So basically everything that you don't need from a plant can go into the process. So basically Europe actually, I think a few years ago, they finished 5 years of the plan of making their agricultural production zero waste. Right? So we talk about zero waste because everything about mass in the waste can go into this production, right? So you can use biochar in an end-use application, and two types. It's a soil application, so that's how I talk about, and you also talk about non-soil application, right? For the non-soil application, the issues that they need to be produced using a high technology rather than old polluting technology, and that put, for example, developing country in a less competitive advantage because they need to invest basically in new technology. Current technology being used in developing country will not be qualified for this market. All right, but again, that opens up a new flow of investment from a developed country to developing countries, and that we will see in the future. All right, so my reflections. It takes years and sometimes that decades for the successful transitions of the technology into large-scale production that can then actually deliver environmental and social benefits to the human society, right? However, carbon credits can form another income stream which actually solve a problem of technology adoption. Because one of the barriers to technology adoption is just, the uncertainty in the investment and the low expectation of return. But if you have another stream income, that will have to solve that technology barriers. However, there is a need for research, and we talk about collaborative research, cross-disciplinary research, because to develop methodology for this, we don't only need economists or life cycle assessment analysis, but we need a more interdisciplinary research. And very proud that QUT has many of these technology. I'm so lucky to work with people here in QUT that, for example, they turn, one of Lin and Saga group here, they turn rye husk into the graphene-like carbon, right? So we don't talk with normal carbon, we talk with graphene-like. And graphene, right? It costs you $1,000 just to buy a little piece, right? And this is carbon, looks like graphene. So you see how much the money we can make, but at the same time, how much impact the technology can have to solve the problem, right? The global problem, actually. And at the moment, Saga and I and others are working on the proposal to establish the research hub. And if you're keen, or if your partners or any of you have any partners, please come and have a conversation. We take a co-design approach, as Uber recommended. So we co-design mean the industry partner, will take leadership in this research domain rather than QUT. And thank you for your listening.